Okay, now I'd like to do an example of how to use logarithmic differentiation to solve a derivative problem. So it says to differentiate y equals h of x. One way to do this is take natural log of both sides. You get natural log of y is natural log of h of x. And then you can use the properties of logarithms to expand this right-hand side as much as possible. And then when you differentiate both sides, on the left-hand side, you're always going to get 1 over y dy dx, because that's just the derivative of natural log of y. We've seen this before, that if you have natural log of u and you want to take the derivative of that, you get 1 over u du dx. And so if you have natural log of y, you get 1 over y dy dx. Okay, so then you'll multiply both sides by y and you solve for dy dx, and then you just replace back in what y was. So I'll show you how this works in action. So first step is to apply natural log to both sides of this equation. So I'm going to get natural log of y on one side, and then I'm going to get natural log of, and then it's going to be x cubed plus x raised to the e of the x. And now you can use the properties of logarithms to expand. So we're going to expand using logarithm properties. So we get now, and maybe I'll do this in black, natural log of y equals e to the x natural log of x cubed plus x. And that's as far as I can expand both sides. So now I'll take the derivative and apply d dx to both sides, and I end up with 1 over y dy dx equals, and now taking the derivative of the right-hand side, I'm going to have to use product rule. So it's going to be the first, which is e dx, times the derivative of the second, that's u prime over u, where u is x cubed plus x. So u is x cubed plus x, u prime would be 3x squared plus 1. And sorry, I don't know why that's popping up. Okay, plus the derivative, or then you do first and the derivative of the second plus the second times the derivative of the first. Well, the second is ln of x cubed plus x. Then the derivative of the first was e to the x. The derivative of e to the x is e to the x. So now I have something, and let me, sorry, I meant to delete all this down here. Okay, so looking at this, we have 1 over y dy dx is equal to this nasty expression over here, which is e to the x plus 3x squared plus 1 over x cubed plus x plus natural log of x cubed plus x times e to the x. So all we have to do is multiply both sides by y now. And we will get that dy dx is equal to, well, y times this expression e to the x times x cubed plus x times, or 3x squared plus 1 over x cubed plus x, plus, and I'll write e to the x over here too, ln of x cubed plus x. Okay, so I just move this e to the x over there. Hopefully you can follow that. Okay, and now the last step is to plug back in for y. We know that y is x cubed plus x, so I'm just going to copy that in there. So we have dy dx, the derivative of y with respect to x, is x cubed plus x raised to the e to the x, that's the y part, times the expression I'm just going to copy down here. Got too fancy for myself here. I don't see the undo button. There's the undo button. Okay, so I'll just write it down. E to the x, 3x squared plus 1 over x cubed plus x, plus e to the x times the natural log of x cubed plus x. And that's all there is to logarithmic differentiation. If you just remember this 5-step process, you should be in good shape. All right, thank you for your time.